Hey everybody, welcome to PGCon 2020 Stay at Home Edition, I guess we'll call this. Welcome to the video. I am Robert Treat. I'm doing a talk on Postgres 12. This is the All Demos Edition. I'm kind of hoping that you didn't walk into the wrong room and this is the thing you wanted to see, but I suppose if that's a thing and it isn't, like, feel free to swing on wherever you need to head off to. That's cool. So a little bit about this talk that we're going to do today. Like I mentioned, it's going to be the All Demos Edition. And this is actually a very hands-on kind of talk. Normally it's very interactive talk. And the way that I do this, I've got a bunch of examples of things that are going on in Postgres 12. Like a lot of these things, you see the feature talks, there's articles, and there's a lot of good information out there. But what I wanted to do is something a little more hands-on, so you can see what exactly is going on. You can play with it a little bit and that kind of thing. So what I've done is I've got a script full of demos that we're going to look at, and you can play it along at home if you want to. The script is available publicly. As you can see, like right here, this is just one of my gists. There's a URL. It's actually easier to get to if you just go to exilla.net/postgres12demos. .html. That will redirect you over to the gist, and you'll be able to find it there, and you'll find all the code. If you look, like, oh good lord, there's all this code that's going to be in there, and that's cool. So you can get the code there. You're also going to need a copy of Postgres 12 if you want to do this for yourself. Doesn't have to be anything special. Here, I'll tell you what, nobody wants to stare at my mug all day. I'll shrink this down over here. I'm going to be hiding over here off to the side. If you need to come find me, that's where I'll be at. But it's okay. So you're going to need a Postgres 12 requirements. We need a Postgres 12. Now I've got one here, and this is pretty simple. I got a browser window up here. I got a command line tool, and I'm just using PSQL, standard stuff. Hopefully you're familiar with PSQL at least a little bit. I'm going to start with a Postgres database. You can see PSQL is 12.1, and the version of my database is also 12.1, so we're pretty good to go there. Like I said, you don't need anything special. This is running on my laptop. This is not a production server. Maybe you're thinking that's where I would do these demos. That's not where I'm doing the demos. Doing this on my laptop. You should be doing this on 12.4, I'm sure, because 12.4 was recently released. But I'm doing this on 12.1. I did compile it myself, but no special options. It's very simple and whatnot. You'll also need a copy for some of these demos. Some of them can run on their own, and you'll see how that works. But other ones, you're going to need a thing that I call the PGCon sample database. The GitHub URL is in there on the script. And it's actually, I have a tab with it over here in case you wanted to see a GitHub page. There's other articles that people have used with this. But what this basically is it's kind of like the old DVD rental store thing. You may have seen in other databases have used that. And DVD rental, it's like Netflix for snail mail, I like to say, in case you're not familiar with that. But so it has, there's movies that you can check out, and customers, and movies have actors, and, all that kind of stuff. So it's a basic schema like that. And the point of this particular sample database is to help us showcase features within Postgres. So that's, what we use it for. It's not like the best practices database or something like that. It's something that we want to be able to put together and manipulate in order to show off new features. So this is exactly the kind of thing it was designed for, and that's why we're using it here. Now, the way this works is, like I said, I've got all these demos in here, and I'm going to just kind of walk you through them. Now, normally when I do this live, like if I do it at a meetup or I'll do it at a conference, if you remember what conferences were, we used to have those back in the day. And in fact, I did this earlier this year at Scale. It was the last conference I went to out in Los Angeles. And then I got sick with something when I came home after that. I don't know, it was very mysterious, but I'm not sure what that was. But anyway, so I went to Scale, gave it there, and when I do it in those places, there's really more material here that we can actually cover, in even like an hour's time. And I'm going to shoot for this to be about 40-45 minutes worth of stuff. And so we're not going to cover everything, and that's fine. Like I said, you can get the script and run the stuff. If you see something you're interested in, go get it. Or you'll collect questions, and then we'll try to figure out a way I can show it to you. What I usually like to do is sort of see what does the crowd want to look at, what examples do they want to see based on what they're doing. Right, so if I'm doing it for developers or DBAs or whatever, we can try to mold it a little bit and get that going. But here, we're not doing that. It's not super interactive. We're pre-recording this one. So what I did is I went and I wrote down a list of, sort of a mix of like things that I think are interesting, things I think you should be aware of, maybe things to clarify a little bit about what's going on with the Postgres 12 release. And so those So I've got kind of that list, and if I can get through all of those, I don't know, that's quite a fair number of them. If I do get through all those, like we'll jump back and through and look at some other ones and see what else is there. But again, like you can always get the script and do it all yourself. Now, so like I said, we got a Postgres 12. You can see it there, and this is a Postgres. I'm sitting here at the prompt. Now, I don't actually have a database, so I just want to show you, like, this is totally, like, I'm going to make the database, create database Pagila, create database, and I'm going to connect to it, and then I'm going to do, let's see if I can remember. That doesn't look right. Yes, Pagila schema? Nope. Let's go Pagila schema. SQL. So I'm loading this up using the /I command from PSQL. It allows you to ingest a file from out there. So first I'm going to load the schema in there. So you can see it's a completely fresh database, not doing anything fancy. I'm pretty sure this will work, hopefully. It will work on a fresh database. I also need to load the data in there because, you know, data is always good. So I'm going to do that. And you see a bunch of copy commands go by. And now we have a database. Woo, shiny and new. It's very pristine, very clean. And we're gonna solve that problem. You know, right off the bat, you can see a couple interesting things. So we've got, like I said, actor table, city, country, kind of standard stuff, customers. We have a partition table in here. Notice payment is the partition table. And then these are the actual partitions of payment. So those tables exist. And with all of that, I think we're good to go. So I'm gonna, now some of that's interesting because a lot of the features that you see in a new release, you know, some of them are very sort of like, maybe it's developer friendly, very visible friendly. Like if you're trying to show off a demo, some of them work really well for that. Other things really don't work that well for that. And I still wanted to talk about them because I still thought they were important. And so, you know, you'll get a mix of that as we're going through. You're going to see some of this stuff is going to look like it works pretty well. Other stuff you're like, what is he even showing? So the first thing we're going to start off with, and this is, like I said, this is how we do it. It's straightforward. I'm going to do with OIDs removed as my first feature that we're going to take a look at. And we'll jump down here. So first, I'm going to create a new table so this is creating a table called with OIDs, right? And it's a single column called X with an integer, and I'm doing with OIDs command. And awesome, syntax error, what? Yeah, so that's actually it's like a counter demo on some of these, like I said. So the with OIDs doesn't actually work in this case because we've actually removed OIDs. That's the point of what I'm talking about. So the with OIDs feature has been removed. If you use that, and I mean, hopefully nobody is using OIDs on their tables anymore. It's really like a legacy option. I think it was deprecated, you know, I don't know, at least 5 years ago, probably 10. I think it's closer to 10 years that has been sort of said, like, hey, nobody should actually be using this. One of the things that's a little bit tricky, though, is that the Postgres developers themselves were still using it. And OIDs have actually always been there. Even if you didn't notice they were always there. I'm going to look at the PG class table, which is, if you've ever looked at any of the system catalog tables, you know, that's probably one. And so if we just do a description of the PG class table, you know, that first column there is OID. And if you had a Postgres 11 and you did that same thing, that OID column is not going to be there. But what's magical on Postgres 11 is you could do something like this. Select OID rel name from PG class limit 5. And that would actually work even though that column doesn't show up in the table description. And the reason for that is in prior releases of Postgres 12, OID was treated as like a special column. So it wouldn't show up necessarily, you know, wouldn't be visible when you looked at certain output. But if you look in the system catalogs, it would still be referenced by the thing. So we had to kind of solve that problem and you know, clean that up a little bit in order for this to really go away and really remove it from the system. Where you were using it, if you did a create table with OIDs, was actually creating these magic OID columns like within your tables themselves. And I think the use case probably most people used it for, and again, like nobody should be doing this, but is if they had tables that didn't have primary keys, you could make these kind of magic OIDs in there, and it would be, you know, basically just a number. That's all these things are, right? These are just numbers, more or less, right? They're OIDs in the system, but they're basically just numbers to have as a unique object identifier, right? OID, object identifier. So like I said, like the right way to handle that depends on your needs, but, you know, either add a real primary key, add a unique constraint, you know, use replica identity if it's like a replication thing or whatever. But that's, you know, that's really how that should work. And so we've taken care of that, and now you'll see that column show up. If you hadn't seen that before, that's going to show up. It's possible that could break certain scripts that you might have if you're doing like maintenance stuff or that kind of thing, where you're not accounting for that column. Potentially that could break a thing. Certainly if you're using this in production on your user tables, that will, you know, that will become a problem because that's not going to work anymore. So probably the answer will be much like the system tables: convert those OIDs into visible columns and just kind of treat them like normal. But that's the first thing that just wanted to sort of show that, and then you can see a little bit how all this is going to work. The next thing I wanted to look at is friendlier, spelling is hard, friendlier config sizing. And I'm going to show you right now. Let's see what my system is set to. So right now I'm set to 64 megabytes for maintenance work mem. And what this friendlier config sizing allows you to do is you can do things like fractional or decimal based things. So if I tried to do this in Postgres, anything before 12, like this is going to throw an error, 21.12 megabytes. And it doesn't matter, you know, that's probably not the number you're going to pick, you know, to each their own. But let's say you wanted to do, you know, like 10.5 gigs or something like that. That might be a little more useful. This is certainly, like, if this was the number that I needed, you know, what I would have to do in an older system, you could still get to this value, but you've got to go do the math and convert it. And the math is not, you know, math is hard, I guess, is what we tend to say. Certainly, like, I don't want to come up with this. And you can see what it actually gets set to internally. It just takes what you're passing in and converting it over to what it needs to be. And so now we see we get basically 21, excuse me, allergies, I swear. We get 21,627 kilobytes on there. So so it's basically doing the math for us and doing that conversion. You know, a lot of these features, like some of these are big features that are going to change the way you work. Other ones are little ones, just make things a little bit easier. That's kind of a nice one to me. It makes things a little bit easier. Staying like right along in that theme of making things easier, we now have a thing for create or replace aggregate. I'm just going to show a little bit of a example here. So if I do \h on an aggregate, so you can see the syntax has been changed, create or replace aggregate. And the way you'd have to do this in the past is, you know, is if you needed to make changes to your aggregate, basically you have to drop the aggregate and recreate it. Now, in most cases, that's probably not too big of a problem, but it could start to lead to issues. I can imagine maybe if you had like a functional index going on an aggregate, that sounds pretty magical, but it's not impossible. You know, something, there could be cases where you might have a dependency on the aggregate, so that's kind of a pain. And it's you know, just a little bit nicer to be able to do the create or replace. The other thing I wanted to mention, just showing you this \h. So hopefully everybody knows \h is like the help for a given command. Here you can see it's create aggregate. We define a new aggregate function, create or replace. The other thing, if you want to see more, because there's a lot of different ways, right? You can see aggregates. This is like a normal way, and then, you know, if you're using like stored procedures as part of it, here's the backwards syntax, backwards compatible syntax that it used to have. The other thing that's nice to just sort of look and notice this, one of the things it's doing in PSQL is it's actually showing us the URL for the command if we wanted to go look this up, right? So we can take these URLs, plug them into the browser, and go look it up. And I guess, you know, I actually have internet turned on, which is probably fairly dangerous. But I'll just plug that in and see if it comes up. Or maybe we found a bug, you never know. Nope, it does come up. So you can see it takes us right to the docs, and here we are. We can see all the same information, and then get all the description if we need it. And so that help command, that help URL has been added for all the commands in PSQL. The only thing I'll you know, give a little bit of warning on is that that URL is hard-coded to the version of PSQL you're in. So if you're in PSQL 12, it's hard-coded to version 12. If you use your PSQL 12 to go back to like a Postgres 10, it's still going to show you the link for the 12 doc. That's probably fine, right? Because if you go to the 12 page and you have a concern, you can get, you know, just click on the other version and that would take you right there. So it's probably not that big of a deal to go to the 12 version and you can click back. So, all right, so that's create or replace aggregate. Like I said, pretty simple. Another one we're going to do, let's see, add entries to enum. It's another one I really like. Let's be a little more specific. Entries to enum. There we go. And I have an enum in this sample database. If you're not familiar with this, so this is the MPAA rating system, which is ratings for movies, right? And so this one is, it's different, I think, in different countries depending on where you're at. But you have rating like a G for general audience, kids movies generally, parental guidance, PG-13, R, and 17. All right, so if in the past, if we wanted to add something in, it was kind of a pain because you kind of had to drop the old, well, there was ways, but generally you would drop the old enum type and then create a new one. And again, just like with the aggregates, this was actually worse because you're more likely to have these dependencies. But you might have these dependencies and have issues with that. And so, we want to make this a little bit easier to deal with if we could. So I'm just gonna copy paste. Also hard. Math is hard. Copy paste is hard. So we're gonna alter type MPA rating, add a value XXX. XXX. Oh good lord. So we get the alter type back, and then let's just take a look at it again, and you can see we've added that in. Now, some people, there were ways to do this. Usually involves like, hacking system catalogs and whatnot. That's a little bit of an issue. I generally don't recommend that. I'm not saying I don't do it. I'm just saying I don't recommend it. So there might have been ways, but this makes it sort of much nicer and easier to deal with that. And I would say check the docs because there's different ways you might want to be able to do this. So just make sure that it'll work the way that you want it to, if you were to do that. So that's adding entries to enum types. Let's take a look at generated columns. This one has gotten a lot of sort of press about things. So there's three things I want to talk about first with generated columns, right? So the first thing is, the idea here is it allows you to add columns to tables. This is the high-level overview. We're going to add a column to a table that's based on generated values from other things within that table, right? And this is sort of the first version of the implementation. There's some scaffolding behind the scenes here that I think will allow us to do more interesting things in the future. But this is actually pretty good right now, and so it's a feature that, feel free to take a look at, and hopefully you like it. So when you make that new column, it's got to be based on computed values between, other stuff within the table or just hard-coded values. It can't reference SQL queries, so you can't do a generated column based on something in some other table. That's not going to work. And it also can't reference other generated columns. So at least not in the first version, we don't quite get all that. But you can still do some pretty interesting stuff with this. So I'm going to grab the first one. And before I run this, let me just take a look at the film table. So you can take a look at it. We've got a film ID, title, description, right? So we're just basically describing things about a film. And what I'm going to add is new column called revenue potential. There we go. Grab that. And I'll walk you through the syntax a little bit. Pop that up one more. Okay, so here we've got an alter table film. That's pretty straightforward. Add column revenue potential numeric 5.2. So this is our database. We want to call it, or our data type. We want to call it revenue potential. Then the generated command kicks in. And so we're going to do generated always as rental duration times the rental rate. And we're going to do that stored. And I'll talk about both of those things in a second. We have here in the table, if you look, we've got a rental rate and a rental duration. So what we're going to claim here for business logic reasons is what we want to call is our revenue potential is going to be the rate of the rental times the amount of time that somebody could rent it. And then that should be the revenue potential. And that's based off of these two other columns, right? And so that's how it's always going to work. And the fact that we put that stored in there means that we're going to actually store this information as it gets generated. So let me go ahead and run this real quick. And alter table, alter film. Yep, we're good. And then I'm just going to grab a couple of rows out of the table here. Grab the first 5 and see what that looks like. So we have a couple of movies, Academy Dinosaur, and you can see some of these math, again, easier than others. But if we have a duration of 6 and a rental rate of 99 cents, then we would expect that to be about 6 cents shy of $6, which is what we get. So these are all, put in there, and it automatically puts the data in, and so we're looking pretty good with that. And there's different versions of this that you can actually do. You don't actually have to store in the SQL standard, and so we've got some scaffolding to make that work better. Let me show you an example here. If I were to insert a new row, and right? So I'm inserting in the film, and I need all the required columns. I'm leaving a bunch of stuff out here, but I need a title, a language, a duration and a rate, and a revenue potential. And let's say I'm going to put in The Rise of Sequel Walker. That was a great movie. Language ID is going to be 1, which is English in our case. The rental duration is 21. The rate is 12. And let's say I put in the revenue potential of, $1 million, right, as they say. And what happens when I try to do this? Kablam, as we get an error back, which is what we expect, because we can't actually insert into that revenue potential, right? It's supposed to be a generated column, not one that we can pass in. And you get an error that basically is telling you can't insert in the column revenue potential. Column revenue potential is a generated column. So that, that kind of is what it is. So let me now grab another film in here. And actually, maybe this will be a little bit easier to look at like this. So let me grab that first film, Academy Dinosaur, is good. We're going to update the film and set the rental duration equal to 5, where film ID equals 1, right? So I'm going to change the rental duration. And if we're doing this right, the way we think we should, that should change our revenue potential, right? If we have a smaller rental duration. So let's see what happens with that. It says it's done, and we go back and select it back out, and lo and behold, revenue potential now is 495. So that works pretty well. If you wanted to see, I guess I can go up and I don't think this will break anything. If I take this revenue potential out, it should work. I think it's always good to change a few things in your demo on the fly so you know it's real. Now I don't actually know what the ID is, so let's do where title. We're gonna regex this thing to SQL law. Great, that should work. If I actually put in my data types, which I'm gonna do. There you go. So 21 and 12 gives you 252. That's probably right. Who's going to check the math, right? Nobody's going to do that. So, okay. So let's go and show you a little bit more. Like I mentioned before, so there's this concept of stored or not stored, that kind of a thing. And if we look in the system catalogs, let's switch it back the other way. Hopefully, \x in PSQL, you can kind of pivot the way the data is going to get shown one way or the other. So I'm just switching back and forth in case you're wondering about that. All right, so let me do this. You can see a bunch of columns in here. This is the PG attribute table. So it's a system table that stores all the attribute information, basically like columns in a table. And there's hidden ones. There's table OID, might be related to OIDs. Xmin, Xmax, if you've had bad days with Postgres, you may have heard of these columns. There's those, and then all the ones from our table we know of. And then there's this new one down here, revenue potential, which is what we sort of expect. We added that column, and then this little S for stored. Now in the SQL spec, you can also do like generated, and it'll generate it on the fly rather than store it on disk. And so we've got some scaffolding in here to make that happen. That isn't in the Postgres 12 release, but I do think it will come eventually. Given enough demand, that'll be in there because we've got the stuff in there. So the devs are pretty smart putting that in ahead of time. I also want to show you this. If you ever want to know about columns and what they're all about. So we have in the information schema, you can get some information about this as well. Column usage is a field or is a table in there that tells you about the different columns in a given table. So here I'm looking in the PGCon catalog, right, on public schema, the film table, and then rental duration and rental rate now have a dependent column revenue potential because that one, right, it needs those values from those other two columns. So we set up a little bit of dependency there. Which should also be helpful, like if you want to go drop something like rental rate column out of your table, that'll toss an error, right? Because revenue potential, I think that's true. I've actually never done that. So let's do alter table film, drop column. This might have issues. Hopefully it doesn't break too much if it does. Okay. Oh yeah, well, we had a view in there anyway, so we couldn't do it because we had a view in there. As I said, like I might have a demo that actually requires this table, so hopefully it wouldn't mess up too bad. But we have a view in there that's going to block that anyway, so there's that dependency. But that should give you a dependency, like, hey, there's another column that's relying on this one, so the system will know it'll do the right thing. All right, so that's generated columns, and again, like I said, I think there's a lot of interesting stuff that'll be able to be done with that. and we can, we're moving down that path. Next thing I wanted to talk about is, this is actually, sadly, maybe my favorite feature in Postgres 12. And I always say sadly, it's like it's a convenience thing, and it's re-indexed concurrently. And I don't know about you folks, but so I do a lot of consulting on Postgres and that kind of thing, and so if you're running Postgres set volume, high scale Postgres, like at some point you probably have had to re-index indexes for one reason or another. And in fact, actually, well, we'll get to the in a second. So let me show you how this works real quick. And this is one of the things, like, there's really not anything to look at. But here we'll do \h, just show you the command. Reindex rebuilds an index. Reindex concurrently is the magic. Oh, look at that. And of course, I will help URL down there. So we now can pass that in. And I'm going to do reindex for post table concurrently actor. And this is not really going to look any different than what you might expect to see, right? Like basically, hey, we just re-indexed everything. It looks like normal, but what's really nice about it, and the reason why it's one of my favorite features, is that it's probably working like how you're thinking this was working. Like it's like create index concurrently. You remember we used to have this old trick. So if an index would get bloated, and I say an old trick as if I haven't had to do this in production, within the last month on some older system. So it doesn't have to be that old. Like if you're in the 9.5, 9.6 category, like you're probably doing these kinds of tricks. But if you had a bloated index for some reason and you needed to clean it up, like the trick that we used to do is you would create a new index concurrently, right? Because a normal create index will basically block writers against the table who are trying to insert into that index. And that's the same problem that the reindex command itself has. And if you try to reindex a table or reindex an index, it would have some blocking that would go on, which could lead to trouble. Now, obviously, it depends on your use case and what you're doing and all that. So what we would usually do is we'd create a new index concurrently. Once that one was created and was finished, the system would go ahead and switch over to start using that one, and then you could do a drop index concurrently on the old one. But of course, like that, requires a little bit of locking itself, and you got to juggle that, and it's kind of annoying. But what you really want is you just want to reindex it, but without blocking writes. And so that's what reindex concurrently is giving us, is the ability to do that. So that's going to be, it's just, like it's a little thing that's going to make our lives easier, but like that's already a thing to me that's stressful enough. I'm really not a huge fan of just scripting out, we're going to create 30 new indexes and drop them and all of that stuff. Like you kind of want something a little tighter than that, and this gives us that. So I'm really happy about that. And I should probably mention that in Postgres 12, there was a lot of work actually done on B-tree indexes to improve their performance and shrink their storage size. And so you may want to look, like if you're doing PG upgrade or, something along those lines, where you're not changing the underlying files on disk, like a reindex will probably actually help speed some things up once you get into Postgres 12, if you've gone the PG upgrade route to get there. So, so it's good to even have that just for that reason, that you can now do those a little more online. Obviously be careful. You don't want to swamp your system with too many things like that, but it's pretty nice, generally speaking. So, all right, let's do alter table vacuum. No, let me do, sorry, per table vacuum options. So we got some new per table vacuum options. These are also helpful if you're doing a lot of re-indexing. You may actually want to do something like this. What I'm going to show you first is this version of it, alter table rental. So a rental table, you can take a quick look at that. It's pretty straightforward. Rental ID, we got a date, right? And then just a bunch of foreign keys off to some other stuff. So what I'm going to do is I'm going to actually set on the table, I'm going to modify the table itself. So new alter table rental, and I'm going to set these two new options, which is vacuum index cleanup off and vacuum truncate off. And hit enter on that, blam. And then I'll explain what those do. And in fact, if you want to see them, let me just move this one over here. And if we go down towards the bottom here, we've got options, vacuum index cleanup off and vacuum truncate off. Okay, so what do these do? Like, why do I care about these? What's going on here? And basically the way, what this is going to do for you is, let's say you had a table where you're doing lots of reindexing. Normally when you run vacuum on that table, it scans, first it scans the heap, right? It scans all your data in your table, and it starts with that. And then it goes and it looks at the indexes and sees, what do I have to clean up over in the indexes, right? Well, if you're doing re-indexing and that kind of a thing, you maybe don't need to actually go vacuum those indexes, right? Or potentially if you're doing a lot of hot updates, you know, or you just, the way that your update patterns work isn't doing a lot of activity on the indexes, it may be faster to vacuum the table and not worry about those indexes, right? Or, I mean, the other thing could be just the other way around, right? If you know that the table is really, really bloated, really bad, you maybe want to skip the indexes and then re-index them later, but you still need to get the vacuum in there. And so this allows you to kind of turn that on or off, and you can do it at the table level, which is really nice, right? So you can do it per table. Vacuum truncate, what that does is when you run a normal lazy vacuum, most people think of it, so lazy vacuum is just a vacuum without really any options. We sometimes refer to that as lazy vacuum, versus a vacuum full, which is going to rewrite the table, right? And takes a heavy lock on the table, kind of blocks access to it, and then it rewrites all the data in the table, and it rewrites all the indexes as well normally. And so that's a pretty expensive operation. So a lot of times you don't do that. But if you're trying to reclaim disk space, people will tell you have to do vacuum full. That's not necessarily true. A lazy vacuum, a normal vacuum, when that runs, if there is space at the end of the page, right, or there's a number of empty amount of space at the end of the table, and that's the tricky part, because usually Postgres is writing towards the end, so this, you don't always see this. But if there is space at the end of the table, Postgres will actually reclaim that space back, even on a regular vacuum without the full option. But that's not always that useful, right? Because in this case, that might be, yes, you've deleted some data or something like that. But if you knew the table was just going to grow back again, right? This isn't a bloat that you necessarily need to get rid of. This is just space that happened to get free. It might make sense to turn that truncate off, because then you don't have to do, you know, you don't have to increase the page space on the file system again when the table grows larger again, right? So you don't have to do that if you don't want to. This, at least this gives you the ability to turn that off. And again, that's kind of a nice thing, you know, for certain tables, because at the file system layer, if we get deep into the internals of this, you know, every time you have to increase the size on disk of the file, right, or you know, maybe create a new file on disk or whatever for that table as you're inserting data, you know, there are some file system level locks that have to happen in order to make that happen safely. And so maybe you don't want to have to go through that again. There's also some, you know, actually there's some pretty corner case bugs. Blam, I've hit those, dang it, that happen with that. And so we don't, you know, you don't really want to see that. And so you can turn that option off. I'm going to do a quick demo. This is a little bit more demoable than the reindex. I'm going to do vacuum verbose on with rental. And what you see is, right, found zero removable. This makes sense. We haven't really done anything in here. I could do something like update rental set, I don't know. Let's go with like staff ID equal to staff ID. And that, now we'll vacuum that again, right? So we're doing some vacuuming here. Now we're, you know, finding some new versions, all that. I got the oldest X-Men, so all that's going on, but I want you to see the difference, right? That's fun. So this is actually so important to what's in there. This is what I want you to see. So we can actually turn that off, even though I have it turned off at the table level. Normally when it runs, it's going to run with the vacuum index clean off and not do the indexes. But I can actually pass in case I feel like, oh, I just did like a big update operation. I actually care about cleaning up the indexes on this run. I can pass that in as an option to vacuum. So I'm going to do verbose on again because I want to see what's going on. And then I'm going to pass in the index cleanup equals on, you know, or index cleanup on to rental. And let's run that. And now you see, woo, I just got a whole ton more of output here, right? We vacuum the rental table. And now we're scanning those indexes. Now you can see that is going on, right? And it does work the other way. If you don't have this turned on, if you haven't done the alter table on your table to turn this off, and you want to do a quick vacuum run where you don't look at the indexes, you can pass that in, you know, just flip it the other way. So again, really nice feature, really good thing. It gets it going there. So, all right, so that is per table vacuum options. Let me show you a couple of quick new system views. Let's take just a moment. This is kind of all in the same. You might be familiar with. There's a PGstat. PGstat. Vacuum. Nope. PGstat progress vacuum. naming things is hard. Maybe you've looked at this, maybe you haven't. This can be used to sort of see if you're doing a really long vacuum on a really large table. You can look in this table and see where the state of that is, like what phase of vacuum it is. Is it doing the heap? Is it doing indexes? Whatever. We've added a couple of new ones. One for PGStat progress cluster. If you're clustering your tables, then this will show you where you are in that process. And then again, we've got PGStat process create index if you're doing index work. Again, very similar. You can see the command that's being run, right? The phase it's in, the locker pid, like all that. What is it blocking? Whatever's going on, you know, partitions involved, that kind of thing. So that's a really quick one, really nice to take a look at that. Oh yeah, this is a good one here. Let me do common materialized expressions. So this is a really nice one. Take a quick drink. All right, so materialized expression. So for those that aren't familiar with what I'm talking about here, there's a way to use common table expressions. And in previous versions, the way the planner would look at that is when you put something in the start of your common table expression, it would actually run, and these are, so common table expression, again, if you're not familiar with it, these are basically with queries, right? Also sometimes called common table expressions. And so you do a with query, and the way that you would do that, and I'll just sort of show you without the explain, let's just do this. See how many awesome actors are named Robert. Oh, what the heck, there's none. Did I break something, or is that just the truth of the matter? Let's try that. No, I don't know. Bob Fawcett. There you go. Let's do Bob. Interesting. I don't know how this example is actually going to work, but we'll see. All right. So if you were to do with, so you can do with A as materialized and then select all from actor. What Postgres is doing behind the scenes is that select all from actor. It's going and grabbing that data, and it's basically in the old version. What it would do is it would take that and it would materialize it, as we see with this keyword, right? So it would go do that piece first, and then in the second half it would say select all from A, where whatever, right? Like your where condition. So that's cool. And people could actually use this, and people talk about this as like performance fencing. So sometimes it would help to make something into a common table expression, put it in a with clause. If you wanted it to actually be run first and do the work there, tell Postgres, do the work here first, and then go and maybe do a join on it to some other table or whatever. I dare say it was almost like an optimizer hint, but I don't want anyone to get, too upset if I said that. So we're not going to call it an optimizer hint, but it was a way to, hint to the optimizer which way you wanted the query to perform. You could move it into CT or not. Well, there's some issues around that. And one was actually that there were certain times where you might want to write the query that way. You'd need to write it that way, but you didn't actually want the performance implications. You really just, there was like a SQL level reason you need to do that. And then, really by default, it shouldn't work that way. So it was kind of a little bit of an issue there, some other things going on. And so in Postgres 12, and this is actually kind of odd because this is not usually how Postgres does things. So I was a little taken aback when this first happened. We've changed the default behavior to actually inline anything that's in a with query with the rest of the stuff, that would be in the select portion. So whatever is up here in your with bits is going to get pushed down into here, and then Postgres is going to just figure it all out. And at first, this scared the bejesus out of me, let's say, because one of the reasons we use with queries is because we need the performance difference. So we actually did quite a bit of testing on this to make sure this was going to work without actually harming us, and make sure that we could run this and again, like, we wouldn't have a performance penalty. I want to show you the explain here. And what's odd is this is what, if you run this on a Postgres 11, this is what your explain plan would look like. Without this materialized piece, right? You do a CTE scan first on A, and then, I'm sorry, you build a CTE first, right? So you do a sequential scan on actor first, which builds the CTE A, and then you do a CTE scan on A to go do the filter of the name. And thinks we're going to get a row back, even though we know differently. Don't tell Postgres. All right, so that's how it would have worked in the past. And now if we run this explain, and like I said, it's a little bit weird because the default behavior has actually changed, we now have syntax to get the old behavior. We don't really need to do that. See, this is the thing. Like, we know, because this query is simple enough, we can easily sort of reason about this, that in that with query that I was building before, if you just applied the filter as you're doing the original scan, like, that would be faster than scanning everything and then going back and going over it again and applying the filter, right? So we can see that this is actually faster. And so, but you may need the old behavior. So if you want the old behavior, you use the materialized keyword, which gives you what would have happened in a previous Postgres release. Now, if you're worried about this from a performance standpoint, I think like it's legitimate to be a little bit concerned about this. But we did a pretty fair amount of testing on some apps that used, you know, a decent amount of with queries on a number of different customers and whatnot. And what we found is like easily, I would say 90% of all queries got faster with this change. And I would say that though, like with this change and other performance improvements that happened in Postgres 12. So even though this seems like it would be very scary, like we were actually pretty happy with the end results. Most all of our stuff got faster or maybe stayed the same, even though the plans were all changed, you know, to be something faster. And then we did have the escape clause to use the materialize if we needed to go back. So that worked pretty well, and we were pretty happy with that. So I wouldn't be too scared about this. Obviously, if you're using this a lot, you know, if you can test it beforehand just to kind of see what the performance is going to look like, that's never a bad thing to be able to test. You know, I would recommend that if you're worried. So I'm going to look at a few other ones here. I know we're getting a little bit tight on time. Let's do explain settings on, because I think this is really helpful, especially if you're, yeah, explain settings on. So first, let me just do show random page cost. So I just have my, right, it's a pretty new cluster, just set to 4, which is the default value. Now, a lot of times when you're doing query tuning, keeping track of what you're doing is part of the, you know, that's the hardest part. The weighting is actually, I guess, the hardest part. And then after the weighting comes keeping track of what you're doing. So here, I'm going to set the random page cost in my session. So this is not database-wide. This is just for me. And if I'm doing query tuning, I'm often setting these in my session, trying to figure out where do I need to go with this to make things work. Well, we have a new option to the explain command, which is settings on. And you'll see exactly how this works, right? So I get a plan like you'd expect. Select all from actor is going to give me a sequential scan on actor. That's really straightforward. But what's really nice is I get this settings outlier here, you know, extra information. It tells me, oh, your random page cost was set to 1 on here. So if you've forgotten that you've changed some things, and, you know, if you get 4 or 5 settings on there and start changing them around and all that, that can be a real issue. So, you know, you kind of got to be careful with that stuff. And I think, man, we're just about out of time, but I want to show you at least, I'm going to do at least one more, because this is pretty cool. This would be a good way to end it. Let me show you. Oh, man, I had more to do. Try to get through them fast. Like I said, there's so much stuff in Postgres 12. Like, you know, a lot of these, I mean, that's how Postgres is, right? These new releases come out, you know, you got hundreds of people that are working on a release, leads to hundreds of features. A lot of them you just don't have time to deal with. You know, and they're very specific to certain things. So check out the release notes, all of that good stuff. But let me show you this last one. So this is going to be copy with a where clause. This is kind of a nice one if you've ever had to deal with this before. So I'm going to, first I'll do a little bit of a select all from customer list just so you can take a look at that. All right, so we got customer data in here. It's all fake data. Don't worry, I haven't violated PII or anything like that. But let's say you had something where somebody came to you and said, like, hey, we need a list of all your customers that are in the United States or something along those lines, right? As a CSV, because that's, you know, we're going to upload your CSV file to a remote FTP server because it's 2020 and that's how we actually do data exchange on the worst timeline. So, okay. So how do I quickly generate that? Now, there's different ways, but this is one way that I like to do it now that I have this option in Postgres 12. I'm going to do the copy command. And hold on, just make this. I'm going to do the copy command down here. Copy, select all from the customer list. I'm going to pull everything out of the table and write it out to a CSV file, right? Which is going to be demo pg12 customer list.csv with CSV. All right, that's simple, straightforward enough. Bam, we got copy done, and it's in there. So, okay, we got a CSV. Now, what I want to show you, I'm going to use this little command. I don't know if you know, not everybody knows this. If you do ! Exclamation point, this basically allows you to escape out of Postgres and run a shell command. So I'm going to run the shell command head, which shows me basically the first, number of lines off of this file that I've created on my file system, right? And so this is getting me to the local for PSQL, so where I'm at. So I just copied that out to that file on my file system. Now I want to just look, and what kind of data do I have? And yep, there we go. I've got CSV looking data that looks like that. So okay, that gets me halfway home. Now what I'm going to do is I'm going to create a table called US customers. And what I want to do is I'm going to do select star from customer list, limit 0. And the reason I'm doing that is I basically just need the same structure as the customer list table. And I don't want to deal with, I could write it all out. This is a lot faster as a way to do that. It's one simple command. When I put the limit 0 in, it doesn't actually pull any data over. It just creates it with the same structure that table would have, right? And it does. I'm not doing any indexes or anything like that. We can take a look at US customers if you want to see it. Looks very much like the other one, but it's very plain Jane, like there's nothing there, right? Okay, so now comes the magic. And let me scroll just up enough so you can see this, right? A little, the zoom, I never noticed this, the zoom window is always in the wrong place. Like it doesn't matter where you put it on the screen, like that's always exactly where you need to then go hit the next mouse button. Happens without fail that at some point you're gonna need that. So, all right, anyways, no digressions, running out of time. Copy US customers. I'm gonna copy this from the customer list CSV file that I created earlier, right? That has all of the customer data in there. I pass in with CSV to tell it it's a with CSV, but then I'm going to add this where clause, and this is the magic, right? Where the country equals United States. So we know we've got some in there. Can we see? Yeah, here's one right here. Jennifer Davis, whom I know a person by the name, but shout out to Jennifer Davis. So in the United States, let's go ahead and run this. Let's see what happens. Allergies, I swear. Okay, copy US customers. We copied 36 lines, and then we can go ahead and see what that looks like. Select all from US customers. And look at that, we're working, it's good. So that's pretty cool, right? Like, so now you've created that table and it's got just your US ones in there. So that could save you a lot of time. I mean, normally, maybe you create table as or whatever, like doing it with copies would probably be faster in a lot of cases. So that's really nice. Look at the time. Yeah, okay, I gotta stop this one. I hope you like what you've seen so far. Again, like you can get this script if you want to and play around with it. If you have questions, come and find me. Usually in the Postgres Slack and then also on Postgres IRC. If you need help, feel free to ask. You can also find me on Twitter as well. I'm at RobTreat2. Feel free to shoot me a note there. And I know Dan is going to collect up questions and whatnot. So thanks, Dan, for having us and doing all this thing. I hope you all have a good time with your PGCon 2020. And I hope to see you at some point in the future. I'm sure we'll all get back together. That's the way it's going to be. All right. Thanks, everybody.